Let's take a look at the application using the method of Lagrange multipliers to find the optimized value of the function subject to the given constraint. The Cobb-Douglas production formula for a particular product is given by f of xy equals 70 times x to the power 0.2 times y to the power 0.8, where x is the number of the units of labor and y is the number of units of capital. Each unit of labor costs $200 and each unit of capital costs $300. If the company budget allowed a total of $30,000 for labor and capital, find the maximum level of production, round your answer to the nearest whole number, and if necessary, round any intermediate calculation to at least 6 decimal places. We are going to optimize this function with the condition that the total going to be 30,000 for the cost from the labor and the cost of the capital, where x represent the units of the labor and the y represent the unit of the capital. That means the constraint for this problem is 200 multiplied by x plus 300 multiplied by y must be the total 30,000. Therefore, the constraint function in the form gx equals 0 is gxy equals 200x plus 300y minus 30,000 equals 0. To use the Lagrange multipliers, step number 1, we're going to form the Lagrange function, the capital F, which is in the term of the function f of x, y, and lambda, where lambda is the Lagrange multiplier, is the function fxy plus the Lagrange multiplier lambda multiplied by the constraint gxy. So the capital F is 70 x to the power 0.2 y to the power 0.8 plus lambda multiplied by 200x plus 300y minus 30,000. The next step, we're going to find the first order partial derivative with respect to x, the first order partial derivative with respect to y, and the first order partial derivative with respect to lambda. For the first one, the first order partial derivative with respect to x, we obtain 14 x to the negative 0.8 times y to the power 0.8 plus 200 lambda. And then the second one, partial derivative with respect to y, we treat the y as the variable. Y here, and y here. Then we get 7 times x is 56, x to the 0.2, y to the power negative 0.2, plus 300 lambda. And the last one, with respect to lambda, that is the same as the gxy or the constraint function, which is 200x plus 300y minus 30,000. And in step 3, we are going to solve the system of the equation containing the first order partial derivative with respect to x equals 0, partial derivative with respect to y equals 0 and the partial derivative with respect to lambda equals 0 simultaneously. We get 14. I'm going to write the negative power as the positive power by writing as the denominator plus 200 lambda equals 0. Same as the partial with respect to y. So 56 x to the 0.2 divided by y to the 0.2 plus 300 lambda equals 0. And the last equation, 200x plus 300y minus 30,000 equals 0. So the first one, we solve for lambda. So lambda is negative 14 y to the 0.8 divided by x to the 0.8 divided by 200. And then we can simplify a little bit more to be negative 7 y to the 0.8 divided by 100 x to the 0.8. Set it aside. The second equation, solve for lambda. Lambda is 56 x to the power 0.2 divided by y to the 0.2 and then multiply by 300 for the denominator. You can simplify further. This one to be 28 x to the 0.2 divided by 150 y to the power 0.2 as a simplified form. Then, since these two represent the expression for the lambda, we're going to equate them. This is negative side and this negative side, sorry. So negative 7 over 100 y to the 0.8 over x to the 0.8 equals negative 28 x to the 0.2 divided by 150 y to the 0.2. Now cross multiply and get rid of the negative side. So I have 7 here, y to the 0.8 times y to the 0.2 is 7 over 100 equals 28 over 150 x to the 0.2 x to the 0.8. And it's convenient for the Cobb-Douglas production function here. The combination of the power make to be the power 1. So 7 over 100y equals 28 over 150x. And then the y itself is 28 over 150 multiplied by 100 over 7 times x. 7 and 28 reduced to be 4. And then 100 and 150, that is 2 over 3. So that is 8 over 3x. So we have y equals 8 over 3 multiplied by x. Now, we're going to use y equals 8 over 3x in the last equation. So 200x plus 300 multiplied by 8 over 3 times x minus 30,000 equals 0. We're going to solve for x at this step. 3 and 300 reduced to be 100. So plus 800x equals 30,000. The left-hand side becomes 1,000x equals 30,000. So x equals 30. If x is 30, y is 8 over 3 multiplied by 30. Turns out to be 80. For x equals 30, y equals 80. The 30 is from the labor and the 80 is from the capital. And we look for the optimized function value. That is the function f at 30, 80. Or it's 70 multiplied by 30 to the power 0.2 multiplied by 80 to the power 0.8. And it is 4602.51. And we round to the nearest whole, so going to be $4603.